In lesson 2, we're going to talk about congruent parts, and we're going to be naming figures in ways that help us see these corresponding parts. So on page 177 in your student workbook, you're going to be doing a math talk. So talking through whether each congruent statement is true or false. So you'll see the congruent statement written like this, okay, with math terminology. And then you'll also see it written here in words, okay, in English. So this statement says triangle ABC is congruent to triangle FED. So what you're trying to decide is, number one, that they are the exact same shape and size, but also, do the points line up? Okay, so does this line up? Is this order making sense? Does this congruence statement itself go with the picture? So you can be kind of thinking about that in your head. You could use colored pencils or highlighters to kind of go in order, naming each of these triangles and coming up with, does it make sense? Is it true? Is it false? You then should talk through that with each other. If you disagree with somebody, then you should talk it through and see if you can come to a consensus about your answer. You can pause the video and come back when you are finished. So the strategy that I'm going to use on here is that I'm going to use kind of the different colors to go in order of the congruent statement. So this one has the triangle going in order A, B, C. So I'm going to first start by connecting A and B. And then I'm going to do the same thing with this second triangle. Connect the first two FE. Then I'm going to do BC and ED. So second and third letters, second and third letters. And then A to C, so first and last, and F to D. So A to C. And then, oh, what did I do? I did it wrong. Hang on. Okay, so the method that I'm going to use is taking a look at doing them in the same order. So the way that you name the letters and the way that you draw the picture. So for this one, I would be going AB first and FE. Second, then I would be doing BC and ED. So B to C and E to D. And then finally, A to C and F to D, that first and last. So A to C and F to D, and see if these two triangles go in the same order. And they do, so this would be a true statement. So this congruent statement is true. Second statement. Second statement, so we've got these two quadrilaterals. So quadrilateral PZJM is congruent to quadrilateral LYXB. I'm going to do the same idea here and connecting in order. So first they do PZ, and then they do LY. Okay, LY isn't even a side of this quadrilateral. So this one is a false congruent statement. Okay, it went totally out of order here. Didn't even give you a side of this quadrilateral. Next one, triangle JKL, congruent to QRS. So let's draw these in order. Taking a look. So JK with QR. Okay, and those are not corresponding sides. So those two are not corresponding sides, so they did not go in the correct order there. You could keep going if you wanted and look at KL. Okay, so KL versus RS, that one you can really tell is different since this is a very small segment versus a large segment. So that would be a false congruent statement. And then the final one. So this one, taking a look at the order again, we've got AB with PQ. Okay, so first two. Then BC with QR. CD with RS. DE with ST, and then that final side, AE with PR. So this one is a true statement. So true congruent statement for this last one. So it's important that even though if you take a look at these, all of these figures appear to be congruent. And actually, if you took tracing paper, they are all congruent. This triangle is congruent to this one. This quadrilateral is congruent to this one. Triangle to triangle, pentagon to pentagon. So it's the order of the letters that matters. So if we take a look at this quadrilateral here, if I do move this over, okay, it is the same size as this one. It's the fact that they mixed up the order of the letters, since you need to be saying that P maps to L, Z maps to Y, J maps to X, M maps to B. That needs to be happening in your congruence statement. Okay, so when you're trying to decide PQR is congruent to which triangle, hopefully through your tracing paper, moving it around, you realized that it's congruent to this one. So we have, and I'm just going to write out triangle, actually let me write it in blue here. So we've got triangle PQR, and then is congruent to what other triangle? So triangle PQR, okay, that's kind of the order that we wrote it in. We did the 5.9 side to 4.3. So in order here, 5.9 to 4.3, we start at M, go to N, and then L to make sure that we get that in the correct order. So then let's take a look and see what the sequence of rigid motions is that helped you prove that. And then you need to draw these, you needed to draw these on your paper. So first thing, I would translate to get one of these points to match up with its image. So either P to M, Q to N, or R to L. I'm personally gonna do R to L. Okay, so I just translated it over there. Then I'm just going to duplicate this so that we can take a look at doing the next one. So now I've got R set, so I've got R and L together. So maybe now I'll rotate Q to N around R. So I'm going to leave R the same, and I'm going to rotate Q all the way over to N. Okay, until Q coincides with N. So just keep rotating until you get Q on N. Then you could do a reflection and reflect P down to M so that it would get all of those to be the same. So get them right on top of each other. Then you'd have this next triangle drawn in. Explain why there can't be a rigid motion from triangle PQR. So from this original PQR, how come this can't do a rigid transformation to this one? Okay, and that's because they aren't the same size. Okay, so this angle E and this AE side and angle C aren't the same. So when if you were to have laid it on here, okay, this angle is the same, this side length and side length are the same, but these other corresponding parts aren't. So AE is not the same length as PR. Angle E is not the same size as angle R, the one it should be going with. okay? And then angle C is not the same size as angle Q, so those corresponding parts weren't the same. All right, then let's take a look at some corresponding parts in this activity 2.3. So they start by telling you that triangle ABD is a rotation to CDB, okay? And you see how we have these colors here to help us. So A rotates to C, okay? B in this top triangle in ABD, so this B up here rotates down to D in this bottom triangle. And D in this top triangle rotates over to D in this kind of bottom triangle. So you can kind of see those happening, and maybe even if I just kind of moved it in here so you could see which angle it's talking about. So A rotates to C, B in the top rotates to D in the bottom, D in the top rotates to, oops, this should say B in the bottom. All right, and so is angle ADB, okay, let me highlight it here. So is angle ADB is what you're trying to figure out. Is triangle ADB, this angle here, okay, the same as triangle CDB? So CDB. So are those two angles the same or not? Explain your reasoning. So in this case, that would not be true because this top kind of angle here, this angle ADB, did not rotate down to this one. Okay, when you rotated it around this middle point right here, this angle D rotated here to this angle. Okay, so angle ADB is not equal to angle CDB, and I would say because they're not images of each other. Okay, because angle CDB is not the image of angle ABD. So unless these two angles here started equal, okay, then they wouldn't be equal on the rotation. Okay, number 2. So this one has two different polygons, okay, and this top polygon, you're going to reflect and translate it over. Okay, so take and reflect this and translate it over. Is segment KJ, so here's KJ, congruent to NM? So is it congruent to NM? So if we take a look here, here's JK in our statement. Okay, so JK is right here in our statement. Is that in the same spot as NM? So if I were to just kind of, let me rewrite these. So HIJKL, GFONM. So if I take a look, here's JK. What is that in the same position as? So that's in the same position as ON. So JK is congruent to ON, not to NM. Okay, so these two segments are congruent, not KJ and NM. So those are not corresponding. JK is corresponding to ON. Those are the two that would be congruent. So then if we take a look in, and if we go back to this first one, so ABD, so if we look at angle ADB, so A goes ADB, so D is the vertex, And then if we look here, CDB goes in this order with D as the vertex. So they're not in the same order in the statement. Okay, like these two, where were they in the statement? So then if we take a look at this one that doesn't have a picture, it says quadrilateral PQRS is a rotation of this polygon. Is QRS, okay, so here's the angle, so that means R is the vertex, congruent to ZYW. ZYW, Y is in the middle, so Y is the vertex in that same position. So I would say yes, these are congruent, okay, because they are corresponding. Even without seeing that picture. Okay, then just kind of the overall synthesis of this lesson is, why is it not true that ABCD equals JKLM? Okay, so again, remember we're looking at order here to make sure that the parts match up. So AB is going with JK in this statement. Okay, those are clearly not the same length. So they are not matching up corresponding parts. Even though these two shapes are in fact congruent, they are the same shape, they are the same size, they're not putting corresponding parts together. Okay, so corresponding parts are not matched up or are not in order. So you need to be naming the point with its image. Okay, where did this transform to or translate to? So A went to L, B went to M, C went to J, and D went to K. So you got to name them in that order. So if we wanted to write a true statement, we would say ABCD is congruent to L, M, J, K. So those corresponding parts are huge. So remember that when we are writing a statement, so you've got, if this is a quadrilateral, it has 4 angles and it has 4 sides. So we're going to get those 4 angle congruencies. So let me just write this LOVE above here. So angle L and M, A and O, V and T, E and H. So those are going to match up along with the sides. So remember, sides have 2 points. Okay, so we've got MA with LO, AT with OV, TH with VE, and then you do first and last. So MH with LE. So that's going to match up those parts. Okay, so you got to make sure you do that in the correct order. So then try this congruence statement with the people around you and to practice writing these in the correct order. Be sure to pause the video and then come back to check your answers. So you can kind of do this how you want, but again, if you could think about mentally rotating this. So I would say that O is going with Y. And so you can do different colors to help you, whatever that looks like. P is going with A. You could even put like a number by them to match them up. So then L is going with H, and then you kind of have the order. So now you know it's going to go in that order. But so for this one, I would say O, P, L, M, N. Okay, because we can't cut across the shape. So O, P, L, M, N is congruent to Y, A, H, F, S, getting those in order. So start here, decide. I think it's easiest to see this kind of vertex that's kind of sticking out. That one looks like X. Okay, I would say then I see this kind of shorter side here. So C would go with W, F with V, and then U with E. And then again, it doesn't matter that where you start here. So you can start with D if you want to. Okay, you just have to do the same order over here. So if I want to start with D, that's fine. I can go D, C, F, E. Okay, so D, C, F, E. So I'm going red, blue, green. So red, X, blue, W, green, V, and then U. I also could have started with C. I could go C, D, E, F if I wanted. So I could go C, D, E, F. The one that went with C was W, with D was X, with E was U, with F was V. Both of these are correct. Okay, that doesn't matter. Just have to make sure that they're matched up with their image. All right, so we've got this kind of shorter segment here, NM, so I'm going to match M with T, N with E, and then you've got U. So I'm going to go M, N, O, congruent to, and we know this is a triangle, so we can put a triangle out front here. Okay, triangle M, N, O with T, E, U.